Good evening, ladies and gentlemen. I am Riley, and I'll be introducing to you today the wonderful element of hafnium. Hafnium, being the chemical element on the periodic table with the symbol of HF, its atomic number is 72. It's a lustrous, silvery gray transition metal. Hafnium chemically resembles zirconium, and is found in zirconium minerals. Hafnium is named for Hafnia, the Latin name for the city of Copenhagen, where it was discovered. It is a shiny, silvery, ductile metal that is corrosion resistant and chemically similar to zirconium due to its having the same number of valence electrons and being in the same group. The physical properties of hafnium are affected by zirconium impurities, especially the nuclear properties, as these two elements are among the most difficult to separate because of their chemical similarities. A notable physical difference between these metals is their density, with zirconium having about 1/2 the density of hafnium. Hafnium does not exist as a free element in nature, but is found combined in the solid solutions for zirconium and natural zirconium compounds such as zircon, which is about 1 to 4% of the zirconium replaced by hafnium. A major source of zircon, and hence hafnium, ores are heavily mineral sand ore deposits and carbonate intrusions, particularly the Crown Polymedical deposit at Mount Weld, Western Australia. A potential source of hafnium is trichyte tuffs containing rare zircon-hafnium silicates at Dubbo in New South Wales, Australia. Hafnium is used in filaments and electrodes. Some superalloys used for special applications contain hafnium in combination with niobium, titanium, or tungsten. Hafnium's large neutron capture cross-section makes it a good material for neutron absorption and control rods for nuclear power plants, but at the same time requires that it be removed from the neutron transparent corrosion-resistant zirconium alloys used in nuclear reactions. Zirconium is a good nuclear fuel rod cladding metal with the desirable properties of a very low neutron capture cross-section and good chemical stability at high temperatures. However, because of hafnium's neutron-absorbing properties, hafnium impurities in zirconium would be caused far less useful for nuclear reactor applications. Thus, a nearly complete separation of zirconium and hafnium is necessary for their use in nuclear power. The production of hafnium-free zirconium is the main source for hafnium. Another use for hafnium is in computer microprocessors. The electronics industry discovered that hafnium-based compounds can be employed in gate insulators in the 45 generation of integrated circuits from Intel, IBM, and others. Hafnium oxide-based compounds are practically high-K dielectrics, allowing reduction of the gate leakage current, which improves performance greatly. Several details contribute to the fact that there are only a few technical uses for hafnium. First, the close similarity between hafnium and zirconium makes it possible to use zirconium for most of the applications. Second, hafnium was first available as a pure metal after the use of it in the nuclear industry for hafnium-free zirconium in the late 1950s. Furthermore, the low abundance and difficult separation techniques necessary to make it a scarce commodity. It is predicted that within 10 years, the world's hafnium supply will be entirely gone. So if you ever plan on building your own computer or nuclear reactor, this is pretty much the metal for you. Even if you just want to brag about the fact that you own one of the rarest elements. After all, in 10 years, you could be one of the only people with hafnium left. Well, that's about it. Thank you, ladies and gentlemen.